In this lesson we're going to look at problems involving the transfer of gravitational potential energy to kinetic energy and back again. Now this type of problem is really common in exam questions. So this is a typical type of problem where you've got a rock on a hill, for example, and somebody pushes the rock, and you have to work out, for example, what the velocity of the rock is when it reaches the bottom of the hill. So first of all we need to know that the rock is at a height h and it has a mass m, so we can say that its gravitational potential energy, PE, is equal to m times g times h. Right, and as that rock rolls down the hill, that gravitational potential energy is going to be converted to kinetic energy. So when it gets to the bottom of the hill, all of the GPE has now been transformed to kinetic energy. Okay, so you say that the kinetic energy of the rock at the bottom is now equal to a half its mass times v squared. Now in this type of problem it will invariably be stated that there is no other energy loss during this transfer. Okay, and what you'll have to do is you'll have to equate these two expressions. We see that the mgh here is converted to a half mv squared here. So what you may have to do is you may have to find the speed of this rock. Now let's give the problem some numbers. Let's say that the rock weighs, say, 50 kilograms, and its the height of the hill is 100 meters, and we want to calculate the kinetic energy when it reaches the bottom. Now I'm just going to suggest that you calculate first of all this explicitly here. So we'll work out the gravitational potential energy at the start, which is equal to 50 times 100, times 10 times 100, which is equal to 50,000 joules. And then we'll say, well, that 50,000 joules has been converted to kinetic energy. So we can now say that a half mv squared, that is the kinetic energy of the rock, is equal to 50,000, because we've assumed that no other energy loss has taken place. So we can say that v squared is equal to 50,000 divided by a half m. M's 50, so a half m is 25, equals 2000, so v equals the square root of 2000 equals 44.7 meters per second. Well, that's a really fast rock. I wouldn't want to get in the way of that. Okay, so you may get another type of problem like this. You've got somebody throwing a ball up in the air, and you're told that the ball has a mass, say, of 100 grams, and it's released with a speed of 20 meters per second. And you're asked, to which height does the ball rise? Okay, so what you've got to see here again is the same type of problem. Initially, this time, the ball has kinetic energy. It's been given kinetic energy this time, and that kinetic energy is going to be transferred to gravitational potential energy. Okay. When all of that kinetic energy has been transferred to gravitational potential, the ball comes to a point where it momentarily stops in the air, and at that moment it is at its highest point in the trajectory. That's what you want to find. So what you're going to do is you're going to calculate first of all its kinetic energy and equate that to the gravitational potential energy. Alright, so again I suggest you calculate that explicitly first of all, and remember that examiners always do this. They'll always try and confuse you with the units, so you've got to keep a good eye out for these. You can't use grams, it's got to be in kilograms. Alright, so you have to convert that to kilograms. That's equal to 0.1 kilograms. So first of all you write out the expression for kinetic energy, which is a half mv squared. Plug those values in, a half times 0.1 times 20 squared, which is equal to 20 joules. Okay, so we then say that what the ball then does is it acquires 20 joules of gravitational potential energy. So we can say that when the ball is at the highest point in its trajectory, its gravitational potential energy will be equal to 20 joules. The expression for gravitational potential energy is m times g times h equals 20. So substituting in again, 0.1 times 10 times h, that's the term that you want to find, is equal to 20, and so h will be equal to 20, dead easy, divided by 1, which is equal to 20 meters. Okay, so again, that's a typical type of energy transfer problem that you will find in an exam question.